In this video, I'd like to talk about ATM MPLS integrated service and differentiated service. Label switching technique is used for MPLS and ATM protocols. This technique uses labels of fixed length, which indicates how to switch packets. Label switching can simplify core network because switches merely look up and swap labels, and the longest prefix margin only be needed to be done once. Besides, it enables traffic management and provides new services. Unlike the Internet protocol that uses variable-sized packets, ATM encodes data into small fixed-sized packets, which are called cells. The fixed size can improve the speed of switch because it makes the scheduling and buffer management easy and can operate packets synchronously. Moreover, because the cell is very small, it can minimize the delays for the sensitive traffic. To avoid overhead and long delay caused by improper cell size, ATM breaks up all packets into 48-byte payload, adding a 5-byte header to each one. ATM doesn't require cells to arrive periodically. ATM header consists of virtual path identifier, virtual channel identifier, payload type indicating whether this is the last cell, cell loss priority, and header error correction detecting errors. To ensure the quality of service, when the ATM circuit is set up, each switch on the circuit will be informed of the traffic class. Constant bit rate means a peak cell rate is specified, and constant variable bit rate means the average rate is specified, but it can peak at a certain level. In ATM, virtual channel identify individual flows of information, and virtual paths can be considered as an aggregate of virtual channels. Therefore, resources can be assigned to virtual paths, but resources may be wasted. Like ATM, MPLS uses label switching technique with hierarchy of labels. However, in MPLS, the size of packets is not fixed, and it can encapsulate packets of various network protocols, so it is protocol-independent transport. To understand how MPLS works, we need to know some important components and their roles. Label edge router operates at the edge of the network. It can push a label onto packets for switching and pop it off packets when packets depart. Label switch router is located in the middle of the network, which is responsible for switching the labels used to route packets. Label distribution protocol is used to distribute labels among routers, and it enables an upstream router to be allocated a label by a downstream router. Label switched paths are established by the network operator for a variety of purposes. Forwarding equivalence class is a set of packets that are all treated the same way, and it is determined at entry to domain. RSVP is designed to reserve resources for an integrated services internet. It provides two types of services: guaranteed service providing delay bounds, and controlled load service, which doesn't have firm delay bounds. Moreover, this protocol also supports group communication. In RSVP, the path message is sent from the sender and stores the path state in each node. Reservation messages are sent from the receiver along the reverse data path to make reservation and ask path message. Differentiated services are designed for classifying and managing network traffic and providing quality of service. Its routers implement per-hop behaviors, which defines the behavior of a switch when forwarding packets. One behavior is assured forwarding, giving assurance of delivery, and the other one is expedited forwarding, dedicated to low-loss, low-delay traffic. Behavior aggregate means that if a group of packets have a common label, so that they will experience the same behaviors. In this network, domain is a group of routers. Boundary nodes are points of entry or exit from domain, and the interior nodes are other points in the domain. Each domain has a bandwidth broker responsible for admission control. This table shows differences between integrated services and differentiated services in terms of unit of operation, service scope, complexity, and so on.